this is, I would say, a project in progress. And so there will be things kind of added and links added and so on and so forth. So this is kind of your home base for a lot of what I'm going to be talking about today. And the topic is schoolyard assessment for climate resilience. And the things that you see on this diagram are things that will help you do a schoolyard assessment. And why would you want to do it? Well, hopefully you'll come to kind of the end of the thing right down there with a case study. And that case study would be taking your schoolyard or site, whatever you've chosen, and seeing if you can improve that site for resilience. And we'll be covering, terms resilience and such in just a minute. Before we get started, though, on Blackboard, also a link, there is climate change and land, and that's from the Intergovernmental Panel on Climate Change. So if you want to kind of get a nice view of this summary for policymakers, a little bit about the overall topic of MiRCLE, which is land cover and land use. So a review from the last time we met, we have this idea of land cover, which is just basically what's covering the surface of the earth, your vegetation, grass, pavement, all of that. Land use is more or less the human element, and the human element then would be cast as agricultural, recreation, commercial, industrial. There are other ways of classifying it as well, but that's kind of the main one. As far as climate change is concerned, both land cover and land use do factor in, but land cover is kind of interesting in the sense that if you are teaching about Earth systems, you can actually, using land cover, kind of speak to the plants that are critical components of the carbon cycle. Your land cover is going to influence your water cycle and influence both heating and cooling. And changes in our land cover can contribute to climate change and to what it is that we are seeing. An important element of studying land cover is to have the recognition that there's a lot of good work out there from, for instance, NASA in terms of monitoring Earth's land cover. There's an array of satellites. There's a whole laundry list of satellites that are taking measurements daily. And there's instruments on the International Space Station as well. Terra and Aqua satellites carry certain instrumentations. One is Moderate Resolution Imaging Spectroradiometer, or MODIS. But MODIS is very helpful in helping scientists create land cover maps. The problem with this is that the NASA satellites are obviously up in space, and we're down here at the Earth level. And so the question would be, can we as citizen scientists contribute to the NASA effort by perhaps doing some ground truthing? That's a little bit of an introduction. Framing climate change is the next topic. These are just some things to keep in mind as you're teaching about climate change. First of all, extreme weather and other events. The idea of this heavy downpours leading to flooding and hurricanes, extreme temperatures, and of course we have lots of wildfires going on right now. So that's an element of climate change. Then we have long-term impacts, which are things like your rising sea levels and changes in range of plants and animals. So they're kind of different layers of climate change that you could be working through with your students. Vulnerability, though, I think this one is kind of an interesting one, because this one is how we have the biological, physical, and socioeconomic system all kind of being inversely adversely impacted by something going on with our changing climate. And this vulnerability idea is kind of, I guess, best explained with, for instance, looking at New Orleans, Hurricane Katrina. You had a big hurricane come through, and that city at that time was very vulnerable. So that's kind of an important climate term. Now, in terms of then these extreme weather events, this is just a timeline. Again, this PowerPoint will be available to you, so you can kind of look through it and see it in a little more detail. But you can see they're looking at the algal blooms, storms and flooding, and temperature changes that have happened throughout the year starting in 2006, and this is just for Michigan. And then it ends up in 2016. So these are some pretty good examples of extreme weather events. Now, the response to climate change, and this is pretty standard climate change lingo, is mitigation, which is reducing your emissions, stabilizing your greenhouse gases, and then adaptations, which is kind of adapting to whatever conditions you have. Word resilience. So now we're back to the resilient schoolyard. So this would be how your land area is going to respond to all these changes. Is it going to be able to take a lot before things really start changing, or is it it's called like climate resilience? The state of Michigan, and certainly a variety of other organizations out there and states, are planning for resilience in many, many ways. For instance, in terms of resilience, there's certainly issues happening at Lake Michigan right now with the high lake levels, and cottages are falling into the water, so on and so forth. So there's a big push for coastal resilience, but certainly other land uses are there as well. And I'd like to share with you something from Elgro, Lower Grand River Organization of Watersheds. And Eileen from Elgro is going to be one of our speakers later. But her group is working on watershed resilience. And watershed resilience is very interesting because she's kind of, and our group are using a little bit of what you might consider if you're doing your schoolyard resilience. And so as you can see on this part of what they're trying to bring to focus groups is they have the land use, so urban, suburban, residential, and I don't have the whole thing right there, but they're asking the focus groups to look at vulnerabilities and strengths of their watershed, sub-watershed actually, and then opportunities. And you see the word GI, and that's like green infrastructure. So there's a lot of people thinking about this idea of resilience. First thing then in our diagram is to find your site. And you could then work through mapping the site, your land use and land cover. And here's an example of, I don't know if anybody knows where that is, but it is a school in the Forest Hills area. And you can see all of the different land uses and land covers. And from there, you could construct a land cover classification map. And here's an example of a couple of schools that have done that. Later on, you're going to see in our agenda of things that are coming up, these types of things will be addressed, so I'm not going to spend a lot of time there. If you are really into looking at land cover, there's a great NASA website called Worldview. It's has very current images of what is going on. And then there's NASA Earth Observatory, where you can look at global maps and see snow cover, chlorophyll, so on and so forth. And then later in our series of talks, there's going to be some information about Landsat, which is kind of another good site for land cover and such. So in terms of your site then, let's assume you've mapped your site. So here's some ideas about your inventorying and exploring your site. And we have a really great group of things in what is known as the Earth Partnership for Schools. And there's a link there. And it goes through this idea of inventorying, investigating, and analyzing. So there's lots of things that you can learn about a site. And by site, if, for instance, some of you who are not having your students back in school, there's no reason why they can't do some of this work kind of right where they live. Okay, so then the next thing would be to take some environmental measurements. And this is where GLOBE comes in. GLOBE is global learning and observations to benefit the environment. GLOBE started back in 1995. We just celebrated our 25th anniversary with kind of a worldwide meeting, virtually, of course. But the idea is to link scientists with teachers and students with the goal of the teachers and students, particularly students, taking environmental measurements in a certain way throughout the world, and then that could be fed into the scientific community. So globe.gov is the landing place for this. GLOBE has a couple of elements to it. The original GLOBE was you would get trained, and it was in person. Remember, 1995, we didn't have all this. But now you can get trained online quite easily. Your school then would become a GLOBE school. And I know that there are some of you today that are GLOBE schools. Might not be doing a lot of GLOBE, but you perhaps are GLOBE schools. A second way to get trained is to do it totally online, and an individual, and I mean a student, could become their own like citizen scientist. So I think that's a really exciting part of GLOBE. As you remember, I just said that students are using GLOBE to take their measurements in a very constructive way through what are known as protocols. And the four main spheres are atmosphere, biosphere, hydrosphere, and pedosphere, or soil. So there's tons of measurements that students can make. If you take training, either way, either as a GLOBE citizen science, as a GLOBE school, what you'll be doing is you'll be defining your site, taking measurements, and then recording your measurements on the GLOBE website, and then visualizing your data. But the caveat is anyone can use the data visualization tools. So you don't have to be trained or a GLOBE school to be able to see that. But here's an example of the protocol ETraining. And you just kind of select there's the GLOBE banner on top. You select Get Trained. And then you go ahead and get into whatever sphere you want. So for instance, here's the biosphere. And say I wanted to download the module on Introduction to Biosphere. The modules are in PowerPoint form, which is kind of cool, because if they're in PowerPoint form, that means that there's probably some usable things from there that I think would be pretty helpful for your classroom purposes. And again, because this is globe.gov, they want to share this with educators and people that can actually use it. So within the module, you can see on the left-hand side, there are many little kind of elements and parts to the module. And so what you do is obviously start at A and work your way through. But by the end of working through this particular module, you're going to be able to define land cover and how these measurements relate to the satellite images. That's kind of a really interesting link to the NASA effort that's going on. They do stress the idea of quality control, very important. And then they have something called the MUC classification system. That's kind of a land classification system. And then you will identify a sample site, and and upload your data, visualize your data. I want to, however, just give a nod to MUC, so Modified UNESCO Classification. And it is something that Globe adopted. And basically, by the time you're done with all of this, you can actually help NASA validate remotely sensed data. So there's kind of a practical aspect working with this. So you're all trained now. So how do you do Globe? Well, you decide what protocols you want to use. You define your study site. You take measurements. All of this is clearly outlined, like on the website. So, not to worry about, having to search for anything, because it's all right there for you. It has your data entry sheets, your study site sheet, so on and so forth, and it tells you exactly what to do. Next thing would be data entry, and you can either do it directly on the website, you can email it, or you can use an app. And speaking of apps, this is the exciting, I think, part of Globe, because this is a fairly new thing with Globe. It's called Globe Observer. So it's an app. And what they're doing is they're kind of offering it to folks in Globe countries. And I think I can't remember how many, but there's well over 100 Globe countries. And it's going to be something that you can use on your phone or your tablet. And you just go get the app, the usual places where you get the app, and it will allow you access to 4 different areas. One is clouds, mosquito, habitat mapper, land cover, and trees. And this is very, very student friendly. For instance, if you're going to have them do clouds, and they could photograph the clouds, record sky observation, and compare them with NASA satellite data, the student will actually get NASA satellite data sent to them. Again, they're kind of doing a little ground truthing because they want to see if what they think they're seeing is actually what it is. That's pretty powerful, I think. Mosquito habitat mapper, this one doesn't quite relate to the land cover idea, but that's kind of interesting one to explore for biology students, I guess. Land cover, they're asking you to photograph and classify land cover in your area. It's a rather large size. I'd like, though, it's the size of a soccer field. But again, it's to give that finer spatial resolution the satellites can't do. Then we have tree heights, and this allows for calculations of carbon in trees. So here we are, like right at the interface of climate change. Data visualization, you've got your data in there, so we're all good with that. But then what happens is when you go to the data visualization part, you select the data you'd like to visualize, and you select the date, and then you kind of take a look at it. So here we kind of pull down menus. So this is atmosphere, and selected a date there, and then I'm getting a data point. So it's pretty easy to use. So let's assume that you are really wanting to get into Globe, which protocols would be good to use. So we're going to take a look at protocols that relate to carbon sources and sinks. So sources release more carbon than they absorb, while sinks absorb more carbon than they release. So trees ordinarily are like sinks of carbon, but they also can be sources, particularly when they're burning up. But just the power of trees. We've got a lot of carbon dioxide removed, a lot of stormwater runoff avoided, and air pollution absorbed. So under the protocol ETraining in the biosphere section, you do have your carbon cycle information. So first one is just an introduction. And if you take the test, you actually will end up with a carbon cycle certificate. That's pretty impressive, right? But there are some more carbon cycle modules. One is standard and non-standard carbon cycle protocols. Standard would be if you had a place that was kind of away from, a bunch of land use things like schools or whatever. I mean, it's more kind of a wild area, I guess that's a way to explain it. but you can set up a carbon cycle site and eventually take some measurements to get an estimate of the carbon storage in that site. And then there's one on modeling. There's another one on green up, green down, and this is seasonal change or phenology. So the green up, green down would be figure out when the fall colors are happening each year, and is there any kind of dramatic shift in when the fall colors are happening, when the buds are starting to burst, such. So again, it's the same look for your training, and it shows you a little bit like how you're going to calculate carbon. You're going to make some measurements, you're going to figure out some biomass information, and then come up with carbon storage and vegetation, and then eventually per site. Also, your protocol flows chart, where you're going to be doing some field learning activities, you're going to be doing your protocols, data entry, so on and so forth. There's interesting research questions that your students could be exploring through your carbon field measurements, and so here's a list of them. I won't go through them because you will have the PowerPoint to look at these more thoroughly. Okay, so that's assuming you're out there doing GLOBE and all of that. Are there some other things that you could be joining up with? Well, GLOBE has what are known as research campaigns. And the idea behind a research campaign is to really get people excited about getting that GLOBE data in. And this one is why aren't there trees in my local environment? The importance of this, and why does NASA and the GLOBE program care about this? Well, in the red box, it says the GLOBE tree height observations can help researchers understand the gain or loss of biomass, which can inform calculations of the carbon that trees and forests can take in or release to the atmosphere. And the GLOBE Observer app has a really neat way of determining tree heights. So the student, all they have to do is kind of point their cell phone at the tree, and it does some fancy calculations. So that's kind of really interesting idea. So this campaign then brings up the idea of tree height, a little bit about the land cover, some carbon cycle elements, and this kind of, they call it Greenings. And this was from a webinar that I attended just last week, where the NASA folks were all there kind of talking about a lot of this. But the idea then would be that students could perhaps help answer questions about tree and land cover issues through student research projects, and then kind of communicate with the Trees Around the Globe student research campaign. And it just really sounds to me like that would be a chance for some authentic science, for sure. Some guiding questions. This is actually for the International Virtual Science Symposium for GLOBE students. And these are some exploratory research questions, so on and so forth. There are other campaigns going on. One is called the European Phenology Campaign. There's Mission Mosquito and Urban Heat Island. So we'll spend just a couple of minutes on these. European Phenology Campaign, they would like you to look at green up and green down and some tree identification. Again, so they can have a little bit better knowledge of global tree distribution and what's going on with our trees. There's another one that relates to one of our parts of the graphic, which is microclimate. So the microclimate part, if you're not, microclimate is a small local region having a unique pattern of weather or weather effects that differ from the local climate. And often microclimates can be found near bodies of water, and we have a lot of kind of urban microclimate situations going on there. And we speak about this idea of heat islands, which are kind of human populated areas with a lot of impervious surface area. And this map kind of shows you the temperature difference between urban and vegetated land due to that impervious surface. And so you definitely can see where the population centers are. It's pretty easy to see that. And I think what's personally shocking to me is just that Chicago to Wisconsin corridor. And it's pretty amazing. And you can actually, on this map, see, basically Grand Rapids, Holland, Muskegon area. So there's been a lot of work on this, the idea of heat island effects. So here's the city of Baltimore. Basically, it's a photograph of Baltimore cut in half. Okay, so the left-hand half is like, certain land uses, and the right-hand, the temperatures, and the right-hand is your typical Google map look. So here we go. And here's the Washington, D.C. heat island effect. And if you go to the website for this, you can actually drag the slider in the middle. And so if you drag it to the left, you'll see, the aerial photo. If you put it to the right, you'll see where the heat is. And so you can kind of relate what's going on with the development of the urban areas and the temperature differences. Well, meanwhile, back to the Urban Heat Island Effect Surface Temperature Field Campaign. This one, what they like you to do is to take the tree heights in, but then take surface temperature measurements, and specifically in shaded surfaces versus the non-shaded area. And again, we're getting at the fact that trees, really play a big role in what's going on with our climate system. And the Globe Surface Temperature Protocol, and this comes from the atmosphere ETraining, is that, basically what you want to do with this is you want to kind of have a little understanding of the fact that you've got different types of land use, vegetation, paved surfaces, so on and so forth, that are likely to have different temperatures, and all of this does affect the Earth's energy budget. The lead on this is Dr. C, and Dr. C goes by that, and he actually has been to West Michigan several times doing globe trainings for us, because Grand Valley State is a globe partner. And we've been doing globe, I think, since, the late 90s, I'd say. And Dr. C is very, very approachable. So if you are really getting into this surface temperature thing, he would, I'm sure, be glad to talk to you. And this is just a video that's online if you want to get to know him a little better. But here we have then surface temperature. And as you can see, it is really, really kind of different whether you're looking at asphalt or grass. And I would like to get one of these thermal imagers that you see on the right-hand side. I think those are really neat. But the Globe Protocol connections then that are in this urban heat island effect, Dr. C would like folks to take air temperature measurements, cloud measurements, and surface temperature. Now, the reason I haven't checked surface temperature is probably your students would have access to a thermometer of some sort. They can certainly observe clouds, but they need a special instrument for surface temperature. It's called an infrared thermometer. They are now relatively inexpensive, and believe me, students love them. So they can kind of point this infrared thermometer at the various surfaces that they're wanting to look at, and really hopefully understand what's going on with the idea of a microclimate. And here's just a whole laundry list of some investigations for your students to do. And again, I won't linger on this. Dr. C and other folks in our globe region are very much into these regional student research symposia. This is an opportunity for your students to do a research project and to present it to other students, and it's a little bit of a competition, I would say. There's a lot of students from the Southeast Michigan area and also Toledo, where Dr. C is from, that have done really amazing projects. So if you're interested in that, there's a link there. All right, so just a couple of other little items relating back to the NASA aspect. My NASA data has a wonderful site there. But if you note Atmosphere Urban Heat Island, like is at the top here, they have a site where you can explore this idea of urban heat islands. This one is surface and air temperatures throughout the day. And then the phenomenon connection, which is this idea of urban heat island as a phenomenon. And again, kind of a good example showing differences in temperature as you go from a rural forest to farms, to city, and so on and so forth. They have what is known as an urban heat island story map. And within the learning objectives of this story map, the students actually will be able to analyze surface temperature data, explore the role of this in Earth's energy balance, evaluate examples of human activity. So if your students are maybe not out there with the ability to use one of these surface temperature IR thermometers, there are ways they can still get into this. And so the story map, as you can see kind of along the top of the banner, is the 5E: engage, explore, explain, elaborate, evaluate. There's NASA connections, globe resources, and teacher resources. So I think it's worth exploring. And here's just a little tidbit from it about how you have a vegetation index related to surface temperature. Another really good thing at this NASA site are the data literacy cubes. So these are worthwhile exploring because they can help guide students with their observations and so on and so forth. Webinars, few webinars. Again, you'll be getting PowerPoint, so you'll be good with that. So we're at the end, almost to the end, where your case study ideas for site improvement. How could you change your land use, do with our land cover? How could our vulnerabilities be mitigated? If we've got heat islands, what about them? What's going to happen to our plants when we have changes in ranges and so on and so forth? How can we store more carbon? How things can be managed and so on and so forth. So there's lots of really, I think, rich questions that do come out of kind of marrying GLOBE with some of those NASA resources to eventually come up with some ideas for site improvement.